Welcome to our channel United Coaching. Today we will discuss top 20 multiple choice questions from the topic carbon and its compounds, and this is a part 2 video. You can check out part 1 video from our playlist, and these questions are the previous year questions from boards like CBSE board, state board, ICSE board and some of the national level exams as well. Okay, our first question is diamond is not a good conductor of electricity because option A, it is very hard, option B, its structure is very compact, option C, it is not soluble in water, and option D, it has no free electrons to conduct electric current. So the option number D over here is correct, and this is the picture of the structure of diamond at the atomic level. Okay, and all the 4 electrons of the carbon are occupied in making the covalent bond with the nearby carbon, and thus a complete lattice is formed in a diamond, and thus there are no free electrons to conduct electric current. Okay, our next question is which of the following when dissolved in distilled water will make it hard? So let me tell you beforehand that calcium and magnesium are the primary ions responsible for water hardness. It's not sodium or potassium, only calcium and magnesium ions. Okay, so option number A, sodium chloride and potassium chloride is not the correct option. Option B, sodium sulfate and potassium sulfate is not correct. Option C, sodium sulfate, calcium sulfate is also not correct, and option D, calcium sulfate and calcium chloride. So this is the correct option. Calcium sulfate and calcium chloride will make the distilled water hard because of the dissolved calcium ions in it. Which of the following is not the use of graphite? So option A, it is used as lubricant. This is true. Powdered form of graphite is used as lubricant in heavy machineries. It is used in the manufacturing of lead pencils. So this is true, we all know this. C, it is used in manufacturing of artificial diamonds. So this is also true. In laboratory, under high pressure and high temperature, graphite can be converted into an artificial diamond. Okay, and D, it is used for making insulated plates. So this option is incorrect. As you can see from the given diagram that carbon forms only 3 bonds with the neighboring carbon and thus has one free electron to conduct the electricity. Okay, our next question is while studying the saponification reaction, what do you observe when you mix an equal amount of colorless vegetable oil and NaOH in a beaker? So option A, the color of the mixture has become dark brown. This is incorrect. A brisk effervescence is taking place in the beaker. Now effervescence takes place when there is an evolution of gas like carbon dioxide or hydrogen gas. So in this case no such thing happens. The outer surface of the beaker becomes hot. So this is true. The saponification reaction is an exothermic reaction and hence a lot of heat is evolved, so the outer surface of the beaker will become hot. And option number D, the outer surface of the beaker has become cold. So this is wrong. Saponification is not an endothermic reaction, it is an exothermic reaction. So over here option number C is correct. Okay, our next question is compound X is a 6 carbon compound. When it is burnt, yellow colored flame is generated. So compound X cannot be. Now over here we have to understand that only unsaturated hydrocarbons give yellow colored flame and saturated hydrocarbons give blue colored flame. Okay, so let's look at the option. Option A, C6H12 is hexene, which is unsaturated hydrocarbon, and that will give yellow colored flame. Option B, C6H14, that is hexane, which is a saturated hydrocarbon, and that will give blue colored flame. Okay, so the correct answer over here is B, hexane. Okay, option C, C6H6 is benzene, and that is also unsaturated hydrocarbon. And option D, C6H10 is hexane, so that is an alkyne which is also unsaturated hydrocarbon. Okay, so all the options will give yellow colored flame except the option B, that is hexane, which will give blue colored flame. Okay, our next question is when you add few drops of acetic acid to a test tube containing sodium bicarbonate powder, which of the following do you observe? Now over here you have to see that acetic acid is commonly known as vinegar and sodium bicarbonate is commonly known as baking soda, and it is also known as sodium hydrogen carbonate. Okay, so let's look at the reaction first. So over here acetic acid or vinegar reacts with baking soda and gives sodium acetate, water water and carbon dioxide. Now this carbon dioxide is evolved in form of bubbles of colorless and odorless gas. Okay, so option D over here is correct. Okay, so first option, no reaction takes place, is incorrect. When acid and base reacts, there is always a reaction. Okay, and the colorless gas with pungent smell is released with brisk effervescence. So this is incorrect. Carbon dioxide doesn't give pungent smell. Okay, and brown colored gas is released with brisk effervescence. So this is incorrect. Carbon dioxide is odorless and colorless gas. Okay, so option number D over here is correct. Okay, our next question is, after the formation of four bonds, carbon attains the electronic configuration of. So these options, helium, neon, argon and krypton, these are the inert gases of the group 18th, and the correct option over here is option B, that is neon gas. Okay, let's look at this figure. This is a cutout of a periodic table, and you can see carbon is in the 14th group, and once it forms four bonds, its octet is complete, and its electronic configuration matches becomes similar to the inert gas, that is neon gas. Okay, so the correct option over here is neon gas. Okay, our next question is a little extra information kind of a question. Okay, now for preparing soap in the laboratory, we require oil and base. Which of the following combinations of an oil and a base would be best suited for the preparation of soap? Now the first option is castor oil and calcium hydroxide. Now you cannot use calcium hydroxide for making soap because it produces an insoluble product when it reacts with fatty acid. Okay, so first option is incorrect. B, turpentine oil and sodium hydroxide. Now sodium hydroxide is a commonly used base in a laboratory or factories, but turpentine oil contains a terpene that can be allergic and might trigger respiratory discomfort. Okay, so this option is also incorrect. And option C, castor oil and sodium hydroxide. So this can be the option. You can use castor oil and sodium hydroxide to make a soap. Castor oil has moisturizing properties, and sodium hydroxide is commonly used base in laboratory. And mustard oil and calcium hydroxide. So again, calcium cannot be used, and mustard oil has kind of a hot oil which causes sensitivity or irritation to the skin. Okay, and anyways, calcium hydroxide cannot be used for soap making. So the correct option over here is C, that is castor oil and sodium hydroxide. Okay, our next question is, ethanol reacts with sodium and forms two products. These are, so first let's look at the reaction. Now ethanol reacts with sodium and forms sodium ethoxide and hydrogen gas. Now students get confused between sodium ethoxide and sodium ethanoate. So the given figure on the right hand side is of sodium ethoxide, and sodium ethanoate looks like this with the carbonyl group, that is C double bond O attached to ONA at the end of the chain. Okay, and sodium ethanoate is formed when carboxylic acid reacts with sodium. Okay, and sodium ethoxide is formed when ethanol reacts with sodium. Okay, so the correct option over here is sodium ethoxide and hydrogen gas are the products when ethanol reacts with sodium. Okay, our next question is, what do we observe on pouring acetic acid on red and blue litmus papers? Okay, so as the name suggests, acetic acid is an acid. Okay, so first option, red litmus remains red and blue litmus turns red. So this is the correct option. When acid is poured on red litmus, the red remains red and blue litmus turns red. Okay, and rest of the options are incorrect, that is red litmus turns blue. So this happens only when there is a base, and blue litmus remains blue. So this is the reaction with the base, probably with the baking soda you can try. Okay, and red litmus turns blue. So again this is base, but blue litmus turns red. So this is acid. So these are two different compounds. Okay, and red litmus becomes colorless. So there is no such thing as red litmus becoming colorless. Either it remains red or it turns blue, and blue litmus remains blue. So this is the reaction with the base. Okay, so the correct option over here is red litmus remains red and blue litmus turns red in when an acid, that is acetic acid, is poured on it. Okay, our next question is a student puts a drop of reaction mixture of a saponification reaction first on a blue litmus paper and then on red litmus paper. So he may observe that. Now over here the mixture, the reaction mixture of a saponification reaction, what they are saying is he basically made a soap, and soap are slightly basic in nature. Okay, so let's look at the option. There is no change in blue litmus paper, so this is true because soap is slightly basic, so blue litmus will remain blue and red litmus paper turns white. So there is no such thing as turning white, so this option is entirely wrong. B, there is no change in red litmus paper, so this is wrong. Red will turn blue because soap is slightly basic, and blue litmus paper turns red, so this is wrong. Blue turns red only in presence of acid. Okay, option C, there is no change in blue litmus paper, so this is true, and red litmus turns blue, so this is also true because soap is basic, so this option is correct. Now there is no change in color is observed in both the litmus paper. This is never the case. Either the solution is basic or acidic, and both cannot show no reaction at all. Okay, so the option number C over here is correct. Okay, our next question is, while preparing soap, a small quantity of common salt is added to the reaction mixture. Which one of the following is the purpose of adding common salt? So this question is also a little extra information kind of a question. I'll just give the answer. It is to favor the precipitation of the soap. Now in this saponification reaction, the soap is in the dissolved form, and to collect it in a solid form, common salt is added, and that precipitates the soap, and that settles down at the bottom of the reaction mixture, and that can be collected in form of a solid soap. Okay, so the correct option over here is to favor the precipitation of the soap. Okay, our next question is, dilute alkaline solution of KMnO4 is, so it is an oxidizing agent. Okay, so let's look at the reaction. On the left hand side there is an alcohol, and on right hand side there is a carboxylic acid, and as you can see there is an addition of oxygen from left hand to right hand side, and this is because of the presence of alkaline KMnO4. So alkaline KMnO4 acts as an oxidizing agent, that means it adds oxygen to the compound. Okay, our next question is, a student prepares 4 different solutions in 4 different test tubes. In which of the following test tube he observes a good amount of lather or a foam? So what he does, he prepares 4 test tubes named PQRS, and the common solution in that is distilled water and soap, and the only difference is of the third option, that is whether he takes sodium sulfate, potassium sulfate, calcium sulfate, or magnesium sulfate. So in all these 4 options we have to see in which one will he get a lather or a foam. Okay, now soaps are sodium or potassium salts of long chain fatty acid, but with calcium and magnesium they form insoluble precipitate called scum. So you will not get a lather or a foam. However, with sodium and potassium sulfate, they form a lather or a foam. So over here option P and Q will give lather or a foam, and option R and S will not give a foam because of the presence of calcium and magnesium ions in it. Okay, our next question is, in the neighborhood of your school, hard water required for an experiment is not available. Select from the following groups of salt available in your school, which will make the distilled water hard. So as we already know, only the calcium and magnesium ions will make the distilled water or any water hard water. Rest of the options of sodium and potassium ions, they will not make the distilled water hard water. Okay, so the option A, B and C are incorrect because they have sodium and potassium salt ions, that is sodium chloride, potassium chloride, and again sodium chloride with magnesium chloride. So option A, B and C cannot be true, so option D is true. Calcium chloride and magnesium chloride will make the distilled water hard water. Okay, our next question is, alcohols can be produced by the hydration of. So the correct option over here is alkenes. Okay, so let's look at the reaction. When an alkene reacts with water in presence of acid, it gives alcohol. Okay, alcohols are typically produced by the hydration of an alkene which has a double bond through an acid catalyzed reaction. Okay, now option number B, that is alkynes. When water is added to an alkyne, the product is a ketone and not an alcohol. Okay, and option number C, that is alkanes. alcohol cannot be produced by the direct hydration of alkanes because alkanes are saturated hydrocarbons with only single bonds, making them unreactive towards direct water addition. Okay, and acids themselves don't take part in the reaction, as in they act as a catalyst in the hydration process, meaning the reaction needs an acid to proceed efficiently. Okay, so the correct option over here is option A, that is alkenes produces alcohol with the hydration reaction in presence of an acid. Okay, next question is which of the following is an aldehyde? Now for an aldehyde, the carbonyl group, that is C double bond O, has to be at the end of the chain, and on one side it has to have a hydrogen and on the other side it has to have rest of the chain, carbon hydrogen chain. Okay, so the correct option over here is the first option. As you can see, the carbonyl group, that is C double bond O group, is at the end of the chain and on one side it has hydrogen, and that makes it an aldehyde. Okay, our next question is which of the following is an alcohol? Now for an alcohol, there has to be a hydroxyl group, that is OH group, either at the end of the chain or somewhere inside the chain. So the correct option over here is the third option, that the OH bond is at the end of the chain and the OH bond makes it an alcohol. Okay, our next question is which of the following is a carboxylic acid? So for a carboxylic acid, there has to be a C double OH group attached to the hydrocarbon chain, and in the C double OH group there is a carbonyl group, that is C double bond O, and on one side it has OH bond and on the other side it has rest of the chain, hydrocarbon chain. Okay, so the option over here, the second option over here is the correct option, that is a carboxylic acid with C double OH group at the end of the hydrocarbon chain. Okay, our next question is which of the following is a ketone? Now for a ketone, the carbonyl group, that is C double bond O, has to be inside the hydrocarbon chain. So in this one, the fourth option has this, the carbonyl group C double bond O has a hydrocarbon chain on one side and on the other side as well, because if it is at the end of the chain, it will become aldehyde, that is chain on one side and hydrogen on one side. So for a ketone, the carbonyl group has to be inside the chain. Okay, so these were the top 20 questions of carbon and its compounds, and if you like our content, you can check out our other playlist, and if you like, you can subscribe to our channel. Thank you.